Thank you for joining this physics lesson. We're going to study the turning effect of a force, or rather the moments. We're told that the figure below shows a uniform wooden plank of length 2 meters and weight 5 Newton. The plank is balanced at a distance d from one end by a mass of 1.5 kilograms. Determine the distance d. Therefore, this is a wooden plank of length 2 meters, weighing 5 newtons, and it is pivoted, or rather balanced, at a distance d, with one end having a force of a mass of 1.5 kgs. So the first thing to do, because we are dealing with moments, there is no moment of a mass. So we change this mass into a force, whereby we say the weight of this is going to be mg, whereby we'll have 1.5 by g, which is 10, so 15 newtons. So the weight here is 15 newtons. Something we should also understand is that whenever a certain system is at equilibrium and it is not balanced at its center, like our case here, its own weight acts through the center and downwards. Therefore, through the center of this wooden plank, through the center, we shall have its own weight, which is 5 newtons, acting downwards. So with two forces on opposite sides of the pivot, we can get their known distances. We are supposed to know that because the whole plank is 2 meters long, then this is 1 meter from the 0 meter end to where the weight is acting. Because the weight should act at its geometrical center, it is going to be 1 meter. So if this is 1 meter, then we can also give this distance a description, and it can be 1 minus d, because from here to here it is d, and from here to the end it's 1 meter. So this is the remaining length, 1 minus the d. Then now we can apply moments, whereby we say the sum of clockwise moments about a given point is equal to the sum of anti-clockwise moments about the same point. So we shall have force 1 times distance 1 being equated to force 2 and distance 2. So we can come up with a force of 5 newtons and a distance of 1 minus d. This is supposed to be a force of 15 newtons and a distance d. That is each force and the distance from the point of support. So this is going to be 5 minus 5d equals to 15. This is d. Then now we group like terms together, whereby we shall remain with 5 equals to 20d. Then to remain with d, we can divide through by 20. So 5 divided by 20, this gives us 0.25 meters. So the pivot is at 0.25 meters, or rather the 25 centimeter mark. Thank you for following. Subscribe and share.